Hello everyone, my name is Niloofar and I'm going to present our work on zero rating and net neutrality in collaboration with Richard Ma from NUS and my advisors Vishal, Misra, and Dan Rubenstein from Columbia University. Zero rating is a tool used by ISPs or internet service providers and CPs or content providers to attract more customers and as a result to increase their utilities. The primary result of our work shows that in scenarios with a dominant market player, zero rating causes a market distortion by reducing the competition. And our findings show that zero rating negates the arguments of net neutrality. In this presentation, we first introduce the setup and our model. Then we go through the concepts of zero rating equilibrium, zero rating pressure, and Herfindahl index, which we use to analyze scenarios where the zero rating options are available in the market. And finally, we present the summary and the findings of our work. The market that we study has two main players: content providers or CPs and internet service providers or ISPs. Content providers are companies that provide content for us, like Netflix and YouTube, and internet service providers are companies that provide internet for us, like Comcast and AT&T. Zero rating is a relationship between ISPs and CPs, and it's defined only for bandwidth limited data plans. When an ISP zero rates a CP, then it does not charge the users for accessing that specific CP, and instead the CP pays for the user's data. The objective of both ISPs and CPs from zero rating is to attract more users. ISPs are one of the decision makers of the market. Suppose we have two content providers, Netflix and YouTube, and two ISPs, Comcast and AT&T. Comcast wants to decide whether to offer zero rating to any of the CPs. It first needs to ask a set of questions from itself. For example, how many users does each CP have? If the CP is very popular, Comcast could increase its popularity via offering zero rating. What is its data price per user? If Comcast offers zero rating, it might not get the same data price. How many users does Comcast have? If Comcast has a small number of users, it could increase that number by offering zero rating. Other zero rating relations. If everyone else is zero rating but Comcast, then Comcast may lose some of its users to its competitors. How many users do other ISPs have? If other ISPs have a lot of users, Comcast could potentially attract some of them via offering zero rating. And how much is Comcast charging each CP? Because it might not be the same as the amount of money that it's charging the users directly. CPs also have to consider similar questions before they making a zero rating decision. The user's decision is also important, and it impacts CPs and ISPs' decision. As an example, suppose that I am an AT&T user, and I'm also interested in Netflix's content, and I know of a zero rating relationship between Netflix and Comcast. Then I might be tempted to change my ISP from AT&T to Comcast so that I get free Netflix videos. To mathematically define zero rating relationships, we first assume that there exists N content providers and M ISPs in the market. We define the zero rating relationship between content provider I and ISP J by theta sub ij, which equals 1 if zero rating relation exists between the content provider and the ISP, and it is 0 otherwise. Then we define capital theta, which is an N by M matrix. For example, assume that we have similar content providers and ISPs in the market, and assume that solid lines indicate zero rating relationship between content providers and ISPs, and dashed lines indicate non-zero rating relationships. Then the matrix theta for this figure would have all of its entries equal to 1, except for entry 1, 1, which indicates the non-zero rating relationship between Netflix and Comcast. We define market shares of content providers and ISPs to be the fraction of the customers they have, and we denote them by phi sub I and psi sub j respectively. We then define dummy content provider and ISP in the market, which are defined to model the users who do not utilize any actual content provider or ISP. We also define auxiliary content provider, which are used to model users who utilize multiple content providers at the same time. Auxiliary content providers include any possible combination of actual content providers. Therefore, if we have n content providers, we would have 2 to the n many auxiliary ones. We assume that users uniquely pick a pair I and J of content providers and ISPs to use, which includes dummy and auxiliary ones as well. Here is an example to illustrate this. Assume that we have 2 content providers, CP1 and CP2, and 1 ISP, ISP1 in the market. We then include dummy content provider, dummy ISP, and the combination of content providers, which would be CP1 and CP2. But then we form a complete bipartite graph between content providers and ISPs. Each edge represents a relationship between content provider and an ISP. For instance, there are 4 users assigned to the lowermost edge of this graph, which represents the users who use both content provider 1 and content provider 2 and access their data through ISP 1. We use generalized Luce's choice axiom to model the probability of a user choosing a specific ISP and content provider. Luce's choice axiom states that the probability of picking item I with weight phi sub I from a set n and item j with weight psi sub j from a set m, which is independent from n, is phi sub I times psi sub j divided by the summation over all the multiplications of weights from the 2 sets. We also define sticky users and elastic users. Sticky users are the users who stay with their providers regardless of the zero weighting profile of the market, and elastic users are the users who choose among the providers who offer zero weighting. Having these definitions, we define the choice models separately for sticky users and elastic users. In our user model, we have X to denote the total number of users in the market, and X sub ij to denote the number of users of CPI and ISPJ. X sub ij could be denoted by a multiplication of a probability function and the total number of users. This probability, P of I and J, is a function of phi and psi, which are the baseline market shares of content providers and ISPs, capital theta, which is the zero weighting profile, and elasticity of the users. We also define P sub j, which is the per bandwidth price of ISPJ, and Q sub I, which is the per bandwidth value of CPI, which is the amount of utility CPI makes per unit of bandwidth. Startups are generally with lower values than popular incumbents. Delta J also denotes the discount that ISPJ offers to the content providers, because the ISPs might not charge the same price from the content providers as they are charging the users, and they might offer a bulk discount. We then use these notions to compute the utility model of the providers. The actual number of CPI's users is computed as the summation over the users of auxiliary CPs, which includes CPI in them. The revenue of any ISPJ in the market is computed as the summation over the revenues that this ISP makes from each of the CPs. And the revenue that ISPJ makes from CPI is computed as per bandwidth data price of ISPJ times its number of users if there is no zero weighting relationship between them. And this value is multiplied by delta sub j, which is the data discount, if there is a zero weighting relation between them. Similarly, the utility of any CPI is computed by summing over the utilities that it makes from any ISPJ, which is computed as Q sub I times the number of users that they have in common if there is no zero weighting relationship between them. But we subtract the price that content provider is paying to the ISP from this value if there is a zero weighting relationship between them, or theta sub ij equals 1. Having these utilities and revenues of ISPs and content providers defined, we then define the notion of zero-rating equilibrium. In a market of ISPs and CPs, given a fixed discount and price profiles, a zero-rating strategy profile is a zero-rating equilibrium if and only if, given a zero-rating strategy theta chosen by ISPs, none of the CPs would gain by unilaterally deviating from it. And also, given a zero-rating strategy theta chosen by the CPs, none of the ISPs would gain by unilaterally deviating from it. Sometimes content providers would make zero-rating decisions and the market reaches to equilibria under what we call a zero-rating pressure, which is when a content provider only chooses to zero-rate because its competitor is doing so. And the objective of the content provider is to avoid losing customers. If the competitor does not zero-rate, then the content provider will not gain by zero-rating. The zero-rating pressure usually causes the low-value CP to have utility loss, but this is not necessarily true for the high-value CP. We then introduce Herfindahl index, which shows the impact of zero-rating on market competition, and is defined as sum of squares over the market shares of all firms in the market. As Herfindahl index increases and it grows to 1, the market moves from a collaborative state to a monopolistic content provider, which means that market distortion increases and it leaves the low-value content provider worse off. To illustrate how the market is impacted by zero-rating, we use the concepts we introduced before and an example of complementary duopoly, where we have 2 content providers and 2 ISPs in the market. We assume that content provider 1 has a low value and content provider 2 has a high value. In the graph on the right side of this page, we show zero-rating equilibria in the market under different ISP prices, where the x-axis indicates ISP1's data price and the y-axis indicates ISP2 data price. Each of the markers also show a different zero-rating equilibria. For instance, star markers indicates when all ISPs and content providers are zero-rating, which is also shown in the graph on the left side of this page, where solid lines indicate zero-rating relations and dashed lines indicate non-zero-rating relations. As the data price of each of the ISPs increase, the number of zero-rating relations that the CPs establish with that ISP decrease because the CPs could afford fewer zero-rating relationships with a more expensive ISP. We also observe that CP1, which is the low-value content provider, generally could afford fewer number of zero-rating relationships than its high-value competitor. The shaded areas in blue and red also represent zero-rating pressure regions for CP1 and CP2 respectively. In a similar market, when zero-rating options are available and the market reaches to equilibrium, the utilities of content providers and the Herfindahl index of the market changes. These graphs show these changes when zero-rating is available in the market and the market reaches to equilibrium, minus when zero-rating is not an option. Figure A shows CP1's utility changes. CP1 is the low-value content provider, and we observe that under some ISP prices, CP1 only observes utility loss. Figure B shows CP2's utility changes, and we observe that CP2, which is the high-value CP, always has utility gain. Finally, figure C shows Herfindahl index changes, which always is increasing under zero-rating, which indicates that the competition in the system is decreasing and the market is moving towards a monopoly. To summarize this work, ISPs and content providers are both decision makers in our model, and each user may utilize multiple content providers at the same time. If zero-rating options are available in the market, low-value CPs usually have utility loss, while high-value CPs usually have utility gains. But regardless of those, the Herfindahl index will always be non-decreasing, which implies that the competition in the market is decreasing and the market is being distorted. Thank you, everyone. Let me know if you have any questions.